All right, in this video, I want to talk about a test of significance. And a test of significance is basically when we're going to look at some of our data after taking a sample, looking at the data and say, is this enough evidence for us to make some sort of conclusion about the mean, or about a statement made about the mean or proportion. So for this one, I'm going to do an example of what we call a hypothesis test. Hypothesis test for the mean. And what that is, well, no, there's no T there. What that is we look at this and say, we're going to have there's going to be a statement made, or we call it a hypothesis. And I'm going to do an example here where, let's say you're interested in going to college and you look in the college brochure and it says the average student studies 18.5 hours per week. Average study time, average study time, 18.5 hours per week. And you think it's a little higher. You think the true value is higher. Because maybe you know some people there, 4 or 5 people, and they all say they study 20, 25 hours a week. And why are they saying the average is this? So you kind of want to do some kind of testing as that. So what happens is we take this first statement that's made, and we're going to call that the null hypothesis. So the null hypothesis, and the symbol for null hypothesis is H naught or HO, and that's that the mean is equal to 18.5. So we start with that as our premise. And then our alternative is what we're going to try to show. Alternative hypothesis is HA, and that's that the mean is greater than 18.5. So we're going to do just take a sample and look at the results of our sample, and assuming our numbers are bigger than 18.5, we're going to see is that sufficient evidence to get that to show that this statement here is not true. Okay, and so let's look at an example here for this one here. So we're going to look at, so we take our sample. First of all, it's right up here. The null hypothesis, the mean equals 18.5. And the alternative hypothesis is that the mean is greater than 18.5. So let's say in our sample, we take a sample and we take, let's say, 10 people in our sample. So n equals 10. And in our sample, the mean that we got, sample mean, is 20.2. Now notice how this symbol is the population mean, because the null hypothesis always refers to the population. And we have here the sample that we got is 20.2. Now this number is bigger than that number. And it's obvious that that could happen, but we know we only took a sample of 10 people out of a whole college, so out of 20,000. We know if we take a different sample of 10, we're going to get a different number than this, and it could be less than this. It might be 16.5 or something like that. So this is still in play. This might be true. We don't really know. We just know that our sample is a lot bigger. So what we have to figure out is what's the likelihood. And that's the interesting thing about tests of significance is there's never really an absolute proof. The only way to prove that this is true would be to interview and monitor all 20,000 people. Not feasible, so we just look at our sample, as I said earlier. So we're going to say, what's the probability that we would get a number this big or bigger simply because of randomness? Now, what I like to think of is this number is bigger than this number here. The sample that we got is bigger than what they stated. And the question is, how come? What is the reason for that? And there's 2 possible reasons. One, it's just because it's a sample, and we happen to take a sample. Maybe if it looked like originally something like this, if it was like this, if when we took our sample, if this still were 18.5, it's possible that when we took our sample, We just happen to grab 10 over here. And that's our random sample. And if I took the average of this group, it would be over somewhere over here, 20.5, to where if I took a different group, maybe over here, it might be down here. So it's possible that this could have been the case. We don't know for sure at this point. What happens is we're looking at what's the reason this number is bigger. It's either because of randomness, something like we happen to grab the red group instead of the green group in our sample. The other possibility is this number is not good. This is not true, and it's actually, this is a true statement. So what we're going to do is try to figure out the probability so we can make an educated decision on this. Let's go back to our sample. When we did our sample, we have to have a standard deviation. The standard deviation from our sample is 2.5. Now, what happens in sample distributions is, let me get rid of this thing here. It's a room. Okay. In sample standard deviations, what happens is if I have 20,000 people, there's billions and billions of different possible groups of 10. If I were to plot each average from all groups of 10, it would look something like this. This is what we're going to call a t distribution. That should be a straight line. This is going to be a t distribution. The reason it's a t distribution and not a normal distribution is because the standard deviation is unknown for the population. So we're estimating it based on our sample here. So this is a t distribution, but it looks similar to a normal curve. Okay, we're going to assume that the mean is 18.5. And we have to figure out, where does 20.2 fit on this? Is it right here? We know it's bigger than that. Is it way out here? And to do that, we're going to get what's called a t-statistic. T-statistic, the formula for that is x bar minus the mean over the standard deviation of the sample. So that's going to be Sx over the square root of n. So in this case, it's going to be 20.2 minus 18.5. That's x bar minus mu. The mu is what we're going to use up here. Over Sx, which is 2.5 over the square root of 10. And when I do that, I get a number of 2.1503. So that's the t-distribution, which kind of tells us how many standard deviations away. So that's going to be somewhere out here. 2.15. And what we're trying to find now is what's the probability out here. Now there are tables or calculators. The easiest way is the calculator, and the calculator actually gives us this number quite easily as well. When we do that for this problem, it gives us what they call a p-value of 0.0300. So a p-value is extremely important. The p-value tells us the probability of getting a value as extreme as we did, or more, simply because of randomness. Okay, so we would, if 18.5 is the actual mean, we're going to assume that to be true and try to show that it's unlikely that we would get this number out here. So what happens is we would, if this were the true mean, we would get a number this big only 3% of the time. So 3 times out of 100 would we get a number this big. Remember, if we took a different group of 20, we'll get something, 10, we'll get something over here, maybe over here. Only 3% of the time will we get a number this big. This should say 20.2. 20.2. Okay, so basically what happens is we have to decide now, is that sufficient enough? Is that enough evidence for us to say, okay, this number's not true anymore. It's true that it's going to be more than this. And what happens is, generally what will happen is we want to create what's called a significance level. And there's no exact values for anything here because we don't know. We have a cutoff point where if the p-value is 0.06, that means one thing. If it's 0.05, 0.04, 0.03, we don't know. We're not sure of anything. We can't be ever sure of anything unless we talk to all 20,000 people. So that doesn't work. But a significance level, and the symbol for that is alpha. So let's say we have a significance level, and a typical one is 0.05, which is a 5% significance level. And so if the significance level is 0.05, that means we're going to use 5% as our cutoff. Anything less than 5% would be sufficient for us to reject this statement and conclude that the mean is actually greater than 18.5. So in this case, since the p-value is less than this, we like to say that we have sufficient evidence to reject the null hypothesis and conclude that the true mean is greater than 18.5. So we're basically saying because this value here, the significance, the p-value we got for this problem is less than the significance level, we have sufficient evidence to reject the null hypothesis. But we might be wrong. There's a chance that we could have gotten a number out here. That's going to happen 3 times out of 100 that we're going to get some number out here. So it is possible, but we're going to say that's too unlikely for us to go with that. So we just basically, in this case, say this value is not true, and we're going to say there's evidence to show, sufficient evidence to show this, or it's significant. It's considered a significant evidence. Okay, I'm going to stop right there.